How are you doing? Tonight we are in chapter 8 of volume 1, Wastewater, Sacramento State. And we're talking about lagoons. One reason why lagoons are typically used in smaller facilities is just the footprint, but they can be used as a secondary treatment or a polishing in bigger facilities. But there are three kinds of process acts upon waste in lagoons: biological, chemical, and physical. The three ways that the water leaves a lagoon system is evaporation from the water's surface, percolation into the soil beneath the lagoon, and a discharge to the receiving water irrigation system or land disposal. On page 695, we can see a typical schematic of how a lagoon is used following the secondary treatment. So you would have your flow meter, your preliminary treatment, your primary treatment, your secondary treatment, and then your lagoons would be used as more of like a polishing tertiary process right before disinfection and removal. The way that you can operate lagoons in multiple different ways. Obviously, you can operate them in series, you can operate them in parallel, in combination of parallel and series polishing lagoons. When we talk about oxidation lagoons, we're talking about those as kind of like you want to think about your primary clarifier, so that um, you have your primary clarifier and then your lagoon one and then your lagoon two. So depending on your application, on what you're trying to accomplish, will be the setup of your lagoon. When we talk about lagoons, we're talking about aerobic lagoons. Aerobic lagoons are characterized by this dissolved oxygen distributed through their whole contents, where anaerobic, as the name implies, usually without any DO throughout their entire depth. And then facultative, if you don't remember, facultative lagoons are the most important type in current use. They're typically 3 to 8. The upper layer of the water is aerobic, while the bottom layer is anaerobic. When we when we're talking about the treatment process, it's important to know that in aerobic lagoons or anaerobic, in aerobic or in the aerobic layer of the facultative lagoons, organic matter contained in the wastewater is used as food by aerobic bacteria, producing carbon dioxide and more bacteria. This carbon dioxide and ammonia in water are very important for algal growth, which is essential to the successful operation of a both aerobic and facultative lagoon. While using sunlight for energy in the process of photosynthesis and carbon dioxide in the water for growth, algae produce free oxygen that is needed by the aerobic bacteria that inhabit the lagoon. The amount of oxygen produced depends on the algae type and the location of the lagoon. At night, when the light is no longer available for photosynthesis, algae uses some of the oxygen by respiration and produces carbon dioxide. The alternative use in the production of oxygen and carbon dioxide result in the daily variations of DO and pH. Now, this is important, and this is a test question that I've seen. During the day, algae uses carbon dioxide, which raises the pH. Then at night, they they produce carbon dioxide, which lowers the pH. How much the pH changes depends on the concentration of algae and alkalinity. So we're using photosynthesis. We're producing um, On page 702, we're producing methane formers and acid formers. And a lot of when you're doing lagoons, it's very subject to the temperature. We're using a natural process to treat the water. In the colder months, you're going to have more struggles in terms um, of your treatment process, especially in those colder months. A lagoon on 703 is generally regarded as not fulfilling its function when it creates a visual odor or leaves a high BOD, solids, grease, or coliform bacteria concentration in the discharge. You know, a, a good practice that we would have is to start the lagoon in the warmer part of the year. Um, we want we want to have a lagoon should have, and this has been a test question on 706. Generally, lagoons should be clear, sparkling green, blue, or brown in color, indicating a healthy algal population. Um, so we want to look uh, at our lagoon, make sure that it has that sparkling green. And one thing as an operator we want to do is test the DO and the pH. Those and those will be indicators of what our lagoons are doing. Once again, as I mentioned before, we need to be careful when we measure those because we need to know that those will fluctuate, whether we're measuring those at nighttime or during the daytime. Managing load. Uh, all all lagoons need to be loaded in accordance with their design. So knowing your influent flow and your influent BOD is important. When you're operating a lagoon. Another thing is our detention time. Are we running this lagoon as a batch or a continuous? When I mean batch or continuous, is it discharging on every day on a continuous basis, or are we discharging it as a batch? And that's the beauty of a lagoon is possibly if you have a big lagoon in a small village or uh, municipality, you can discharge, maybe a couple times a year. And so another thing we need to make sure are we short circuiting? Are we using our whole lagoon? Headworks and screening on page 718. The bar screen should be cleaned as frequent as necessary and should be inspected once or twice a day with more frequent visits during storm periods. Storm periods, you're going to have a lot of flushing of the system. And so, you know, any plant that you should have, we want to make sure that we're checking the headworks during a rain event because it will blind the screen. Scum control. Scum accumulation is a common characteristic of a lagoon and is usually greatest in the spring when the water warms and vigorous biological activity resumes. Ordinarily, the wind action will break up the scum accumulation and cause the scum particles to settle. Odor control. Odors are a concern at most treatment facilities, no matter what kind of process you use. Um, but odors are more likely to occur um, when the microorganisms become more active and may use up available DO rapidly, creating anaerobic conditions. Anytime we have anaerobic conditions or we are overloading our lagoon, we need to we could get odors. Weed and insects, weed and insect control. If If we get duckweed that's so thick over that the duckweed could actually stop the sunlight penetration and hinder surface aeration. Um, we need to remove any kind of vegetation around the dikes of the lagoon. Um, it's recommended that you do that by hand, but if you have to use herbicides, that should be your last ditch effort. It's if you have a wave action and the waves are um, eroding the bank, you might want to put some riprap in that. Sludge management. Sludge management on 725. When the solids start floating to the surface of the lagoon during the spring or fall overturn, the lagoon may have to be taken out of service and cleaned. So once again, just knowing when you have that spring and you're like, what is an overturn? It is the almost spontaneous mixing of all layers of water in a reserve or lake when the water temperature becomes similar from the top to the bottom. Um, we talked about levee maintenance, algae control. It says, unfortunately, there is a little an operator can do by changing the lagoon operating procedures to effectively remove algae from the lagoon. F1. The best approach is to operate the lagoon in series to provide a polishing lagoon at the end of this series in which the algae might die and settle out. Liners, you may have a lined lagoon, you may have an unlined lagoon. It's like a rubber matting that lines the lagoon. Obviously, if you have a liner, you're not going to get much percolation. On 731, overloading. We can overload our lagoon with septic hauling, large amounts of BOD. And once again, winter conditions on 732. During the winter, the lagoon may be covered with ice and snow. Sunlight is no longer available to algae and oxygen cannot enter in the water. Without DO available for aerobic decomposition, anaerobic decomposition of the solids occur. Anaerobic decomposition takes place slowly because of the lower temperatures. So knowing, your seasonal changes is important in your lagoon system. On page 736, there is a troubleshooting guide for your lagoon system. I highlighted this on 739. It said probably the most important analysis can be accomplished easy by any operator or routine uh, pH and DO. A good practice is to measure the pH temperature and DO in a lagoon several times a week and occasionally during the night to determine the status of the lagoon. And these should be tabulated. Those records should be maintained. It would not be a bad idea to check the alkalinity. When we talk about aeration of lagoons, you can have surface aerator, a good picture of surface aeration is on 744. So you can surface aerate the lagoon, but you can also have submerged diffusers. And on the bottom of um, 745 is submerged diffusers. Well, I hope you have a great day, and thank you for listening to this short and sweet on lagoons.